Welcome to the Bell Tech Talk segment of the Vertical MRO podcast. This segment takes you into the nuts and bolts of helicopter maintenance. It's about safety, support, and operational readiness. Top priorities for the Bell team. Join us for technical insights and personal stories from the front lines of helicopter maintenance from the industry-leading experts at Bell.
Hey, welcome back, everybody. This is Val here at Vertical MRO, and we're back for the Tech Talk number 3. Number 3, no tech talk, no TikTok dancing unless Greg's going to do it. We're still not dancing on the show yet. So today's awesome topic and today's speakers from the Bell group and family here. The speakers are going to be Greg Judd. Good day, Greg. And then Martin Malhat.
That's good.
That's good, yeah. Okay. Today's awesome subject is, and it's one that's probably been, you have a lot of these experienced techs that are going to be kind of like, yeah, it's about time we finally talked about this. So I'm glad we are talking about it. Track and balance, baby.
Yep.
So to that. So Greg, welcome back to the show, my friend.
Oh, thank you. Happy to be back. It's good.
You're kind of a last minute sub, but I'll take you.
Hey, we have to do what we have to do. So it's all
shift on the fly, baby.
That's right.
Shift on the fly. And Martin, I'll let you kind of explain a little bit who you are and what you are to Bell, please, if you don't mind.
Been with Bell for over 25 years. I moved back and forth between engineering and mechanics, and I spent most of my time at Bell Experimental. So I've seen I work on development of 429 and 505 from white sheet from scratch.
Wow.
So yeah, that was really good experience.
Great from cradle to finish.
Yep.
Nicely done, sir. Congratulations. That's an accomplishment and a half. You got to see two superior aircraft like that right from paper.
Just lucky. At the right place at the right moment.
Come on. Well, you know what they say. You got to be good to be lucky, my friend. You got to be good to be lucky.
Better be lucky than good any day of the week, right?
And just to bring everybody up to speed on back what Mr. Judd is all about, just give yourself a quick little intro here, buddy.
Yeah, sure. Manage the CSEs for the Americas. Been with Bell for 11 years. Worked in the field before that quite a bit. A lot of 407 experience, medium experience, long ranger, jet ranger, and just happy to be here.
Love to have you back always. We always love to see that smiling face and in person and on the podcast, my friend.
Right on. I'm happy to be here.
Love to have you back. Let's get right into the weeds of it here, guys. We're not going to introduce anything. Here, I have my strategically placed vertical MRO. Hey,
there you go. Right on.
Like I was saying, let's get right into the weeds here. I got two awesome experts here on the guests today on the Vertical MRO show. Track and balance is the topic of conversation. Let's get into it. What is track and balance? Over to you, Martin.
Okay, a basic definition of a helicopter. It's a bunch of parts and shaft spinning at different RPM and trying to stay as far as possible away from each other. So I don't know if you agree, Greg.
It's important. Yeah, that's that. Yeah, that makes sense. Yep.
Organized chaos.
Yeah, I can't tell you how many times I've ever explained that to anybody. Like, so what makes a helicopter cool? I'm like, dude, it's a orchestra of chaos.
Yep, that's right.
Yep, it is. So, you gave us a quick little definition here. Greg, you want to jump in on any of that, or?
Yeah, sure. We spend a lot of time as tech reps. We spend a lot of time helping troubleshoot, vibration issues, track and balance issues, and all that. So we get our hands on a lot of different models, and we thought it'd be good to, share some of the basic things we see that can really make you pull your hair out. But it's simple stuff. When we get a call from a customer saying, "Hey, I'm having a hard time getting this, 206 balanced or whatever, whatever model it is," we usually start with some basic questions. Hey, make sure your gear's installed correctly. We can tell by the information they're providing to us if they have an accelerometer upside down by the direction the moves go. If their channel A and B are mixed up, we can tell by the amplitude typically. So don't get offended if we ask you right out of the gate, hey, double check your installation, triple check your installation, make sure your accelerometers are oriented correctly, make sure the channels are hooked up to the correct channels on the collection equipment. We use the RADS, which is a GE product, rotor analysis and diagnostic system.
Mm-hmm.
And we've been using the Honeywell ZTE kit as of late.
Okay.
Now I think, and Martin, correct me if I'm wrong, but I think we're going to the RADS NG as some of the equipment we're using.
Yep.
the next gen rads.
That's correct. Yep.
Looking over at the outline of this, and I think we're going to touch base on some of this as well too. So this is going to be a well covered podcast on this one today. So, yep.
Yeah. So at the end of the day, I had it explained to me when I was a young technician. You're trying to get to the center of lift over the center rotation on a rotor hub. So you're trying to find point, get that lift right over the top of the mass nut. That's what you're doing. And good track, all that works in your favor when you're getting the track cleaned up. That works in your balance favor, and your, two-bladed rotors versus four-bladed rotors. Now we're going to be dealing with five-bladed rotors on the 525 going forward. So we got a lot of busy stuff going on there.
Greg, it also kind of taps into what I've spoken to you more than a few times already. Your expertise of your team and the knowledge and the tribal knowledge that you guys kind of hand down to not only with your inner customers, but to your customers in itself. So yeah, kudos to you guys kudos to you both for kind of doing that and kind of being patient with the customers. Sometimes we're educated individuals, but when we have to call upon the experts, then we've hit our wicks, right? So
yeah, exactly. And we understand the frustration because we've all been there. I mean, I can tell you horror stories about early on, 52 starts on an aircraft and you're not making any progress. Stop.
Yeah.
If you're not making progress, stop. Don't burn any more slack. So the point is, we understand the frustration and we know the pressure that's on the maintenance department to get these aircraft up.
Awesome. Well, then let's jump right into it. Here, I'll leave it over to you, Martin. Let's briefly explain what one-per-rev is.
One-per-rev, it's a vibration cycle, like every spin of the rotor. There's two kind of one-per-rev. You have a vertical one-per-rev, which it's an unequal lift of the blades, and there's a lateral as well. So you can fix a vertical with pitch links and trim tabs, and the lateral vibration is it could be on a two-blade system. It could be an alignment blade problem or a delta in the blade weight.
Yeah. So to Martin's point, we even use a hub weight for vertical vibration on some models. 407, 429, 412, you can use a little hub weight to clean that up and fine tune it. So we use the whole basket to make this work. On the two-bladed rotors, it's pretty simple. Well, relatively speaking, you have span weight, cord weight, tab, and you can use lead lag as your cord weight adjustment as well. So you have a lot of tools in the toolbox if you're willing to go, if you have to go that far to get there. And on our two-bladed rotors, a few years, I don't remember exactly when, Martin, you may remember, but we introduced an inboard tab at some point years ago because we had situations on our two-blade rotor where you would just shoot parallel to the zero. You couldn't get there because now we call it the shaded area on the chart. You have to disrupt that rotor and move it around the clock. And we'll talk about all sorts of clock corrections and all that stuff. But in short, what we use to fix the vertical vibrations, PCL, hub weight, tab, and span wise, you can use span wise to adjust track to bring one blade down on a two-bladed rotor. And then the lateral stuff, we use a lot, essentially hub weight. The fore and aft, we call it fore and aft on the 407s and 412s and 429s. We call it lateral on the 206s. And it's relative to where the accelerometers are mounted. But
now imagine that when you're adding a fifth blade into it.
Yeah. Well,
yeah.
I may have worked on a few five-bladed rotors in my
I think we spoke about that a few times. Yeah. Yep.
I'm sure Martin's messed with it a little bit as well. So
again, you count upon your expertise and your tribal knowledge to hand down to those young bucks that are listening and listen into your own facilities as well there too, right? So we covered that. Let's go into the N-per-rev, the two-per-rev, and four-per-rev.
Yeah. Can you fix that, Greg? If you can, tell me how. Yeah, it's natural. It's there. There's nothing you can do. What we're doing, it's you can use a nodal beam like on the 206L. You can use live mount 430, 429, 505, and a fram. A fram, it's just a mast mounted on springs that react at the opposite of your N-per-rev, like in two-per-rev or four-per-rev, depending on the 429 as an example, or a 206.
I was just going to ask you with that there, Martin. I know we kind of went over a little bit of dialogue here. what's a FRAM? The FRAM FRAM.
Yeah, it comes from the inventor. It's a German guy who invited that. It's a mass mounted on springs, and it reacts. If you take the 429, there's 2 FRAMs under the floor. The 430 has 3 FRAMs, and the 505 has 1 optional FRAM in the cabin. So it kills the vibration locally.
Okay.
We have as well the FRAM for the 407 that was mounted on a mass. Not all of them. What's the ratio, Craig, in the field that they're using the FRAM on the 407?
I would say probably about 25% of the aircraft have them, 30% maybe. We don't deliver them with the FRAMs on them anymore.
Okay.
So to be clear, two-bladed rotors are inherent with two-per-rev because of the two-bladed rotor. Four-bladed, four-per-revs, right? So you can get a two-per-rev on a four-bladed rotor. And how that happens, there's a couple of ways, but the most common we see, like on our 407s, is the product balance weights aren't managed correctly, meaning they don't maintain the correct mass between forward and aft pockets out there on opposing blades, and that will give you a two-per-rev that will drive you nuts. And typically when we're taking readings on a 407, we don't have limits for a two-per-rev. If we're looking for a two-per-rev, it's because we're feeling something in the airframe that's not being registered on the equipment on a 407 or 412 or whatever.
Gotcha.
Pendulum weights can give you some weird stuff going on a hung up pendulum on a 412 can give you a ratchety pendulum. They can give you some different frequencies, but the short story is a four-bladed rotor is inherently has a four-per-rev in it, and we can manage that by FRAM dampeners, and by the live mount helps a lot with four-per-revs too. Like on the 429 and the 430, we have with these liquid inertia vibration. I forget the whole acronym, but if they lose their charge, 505 has it as well. If they lose their charge, then the four-pers are more pronounced. So if we're troubleshooting,
so is it common to have a 4-for-2?
No.
Or is it no? It's rare.
Yeah,
4 FRAM to the 2. Yeah.
Yeah. So it's either a 4-per or it's a 1-per on a
Roger that
rotor. Yeah.
Okay. That got it. There's already, like, here we are 15 minutes into this conversation. There's a crap ton of moving parts already. So that's, all of this kind of comes into the balance of it all. And there's and this is, how's this for a segue? How's the harmonics? Because it all has to come into some type of harmony for this to kind of operate. So explain to us, the harmonics behind it all.
Okay, an harmonic it's a multiple of the basic frequency. Sometimes people they mix up resonance with harmonic. Resonance is 2 parts reacting against each other from a very close frequency. Harmonic is a multiple of your driving frequency: 1-per-rev, 2-per-rev, 4-per-rev.
Yeah, and we try to manage those with the different pieces of equipment, right? The harmonics, and it's good to note that when you customize an airframe like a 407 or a 429, you can change the natural frequency of that airframe by making it more rigid with equipment that's installed in either internal or external. And that changes the whole way the coefficients react to that airframe in our programs and our track and balance gear. Correct, Martin? Did I say that?
That's correct. Because in design, experimental, we were fighting with that every day almost. In a perfect world, which is never the case, you're trying to stay.
What are you talking about?
15%. Trying to stay away 15% apart from your dominant frequency, which is not always the case. So in that case, yes, there's 2 ways to move a frequency. It's either you add weight or you change the stiffness. Why are we putting weight? It's because it's cheaper, it's faster, and it's efficient. If you choose to change the stiffness, you have to go back in design. You're talking costs and engineering time and delay on the schedule for certification.
Gotcha.
An example for that, Greg, I know you remember the early 407, you had those tuning weight on the X-Fin. And now we made an average. Now we're building the Oxfin all the same. Same for the tail weight on a Stinger. I have a little story on that. I was in production at the time, and Harrison Ford had his brand new 206L4 with a high altitude tail rotor. And we had a real hard time in production with that tail rotor. And right on the delivery, I don't recall if it's that Saturday or Sunday, but it was in the weekend. They called me at home and said, the pilot complained, doesn't want to take off with the aircraft. I said, okay. So came to work and installed the rods, and we had something like 4 or 5 hips on the tail rotor. So, oh my God, we didn't see that in production. So what's happened? So we decided to detune. So we basically tape a bag of lead, 10 pounds on the stinger, and the vibration went away. Okay. So we went to engineering, and engineering said, no, you can do that. I said, okay, tell me what to do. But I'm telling you, there's a resonance condition. So that's why we have this tungsten block attached to the stinger. It's the same for the 407 now. And
505.
We had a hard time with the 505 as well. So at the beginning, we had the same situation, but with experience, now we know.
Yeah, and to his point, on the 505, when we're bouncing the tail rotor, we'll hang weight on the stinger to get rid of that resonance, and then we get the tail rotor in. And once you get that in, once you get the tail rotor tight and balance-wise, then you don't have any issue with it. But there's some black magic going on there. Let's put that.
as technical as we get on this show,
Yeah,
You mentioned something here earlier there, Martin, with the Renaissance condition. Give us just a little bit of explanation, just a little more detail on that. You said it was just two moving parts in opposite of each other.
No, resonance is two parts very close from a frequency point of view.
Okay.
And they talk to each other and they excite each other. So we have an increase in vibration, and you don't want that
as they get further apart.
Exactly. So you want to either increase or decrease the vibration of one of the component to keep them away, like, let's say, at least 10%.
Okay. I was going to say, like, my quick notes here was saying, try not to be at least 15% apart.
Yeah.
I gotcha.
Yeah.
I gotcha.
In a perfect world, but there's so many pieces and shaft and gears and engine and transmission. It's almost impossible to be 15% of everything.
Yeah. And we see it a lot. We see it a lot on like the 407 models where we balance the oil cooler blower. We'll see that translate into main rotor ride issues. We'll see tail rotors translate into main rotor ride, where you get a reading, but the main rotor's okay. It's just getting a resonance from another vibration source in the airframe, whether it's a tail rotor, oil cooler. So that's why we're specific in our sequence of what you check: your tail rotor, cooler, tail rotor, then work your main rotor. Because we've seen, we've learned over the years that you can create some of your own problems if you're not careful.
Gotcha. Greg, I'll put this one over you, because Martin's, you've been fielding some pretty good ones so far here with that, kind of, you can chime in as well there, but Greg, over to on how to move a natural frequency.
How to move a natural frequency. Well, we use product balance weights to move natural frequencies a little bit, but you're going to have to help me, Martin. I don't remember.
I thought I'd give him a bit of a break, but Martin, over to you, buddy. Here's the serve.
Okay. There's only two ways we spoke about a little bit. Is change the stiffness or change the weight of your part. That's the only way you can move your frequency away.
Gotcha.
So that's as simple as that. If you add weight, you decrease your frequency. And if you increase your stiffness, you increase the frequency.
I know it says here with like the tuning the weight on aux fins on early 407 editions.
They were tuned one by one. So now we have a standard weight for the aux fin. So that's why you don't see those anymore.
For 407 stinger weight kind of thing?
The stinger weight's still there.
Okay.
It's still there. Yeah, it's still there. Yeah, that was early on when we didn't have good control of the manufacturing of the aux fins, right, Martin?
Yeah.
We were, well, I shouldn't say we didn't have good control. We didn't realize the importance that we could go to a certain fixed weight and not have to do that anymore with the fins. So,
yeah, 407 was quite an experience from a dynamic point of view early in the program. All kind of issues, TB panel tracking, fram tuning. It was not very successful, and that's why probably now we don't see that many frams around.
Yeah, you can definitely feel the ride difference with a fram on a 407 versus a fram not there, and you only feel it on the high speed stuff. It's like a gravel road feel.
But do you want to feel a gravel road feel in the air?
No, you don't. But it's but the way we mitigate that now is instead of trying to, if you get the one pers way low, then the four pers are more pronounced. So if you manage your one pers around like 0.12, 1.3, you don't feel the gravel road at all. Right around the 0.1.
Yeah.
It's, inches per second is pretty good. If you get them, and you can get a 407, if the components are tight, you can bring them all well below 0.1, but you'll start feeling this four-per. And just on that note, some of the things we see in the field that contribute to four-pers are like loose doors, loose landing gear hardware, stuff like that will actually enhance the four-per revolution vibrations in the airframe. So if
Gotcha.
if your door latches aren't adjusted tight on a 407, they'll start to resonate the four-per because they're feeling every beat of the rotors that comes around, that air's impact on the fuselage.
Yep.
And you get this, you feel it in the airframes.
One of the first to be impacted, I'm sure of it, right?
Yeah.
First to be impacted,
I know it sounds crazy, but check your doors.
This
Check
is the
your
show us
landing
heli.
gear.
This is hey, listen. This is a show that us heli nerds love, right? This is we can talk about this stuff, and this way, like bless my wife and when talking in helicopter stuff, she's just like,
Yeah.
Meanwhile, if it's just us, we get it.
We get it. Yeah.
Yeah, we get it.
It's a world we live in. Oh, just to finish up the 407 thing.
Yeah.
We'll probably talk about it later, but correct me if I'm wrong, Martin, but the 407 was the first soft in-plane rotor hub that we certified.
Commercially, yep.
Yeah. And that's different than a soft in-plane is different than an underslung two-bladed, like our long rangers, or fully articulated, like the 525. And they respond different to adjustments than any of the others. It's important to note that because if you've only worked two-bladed rotors your whole life, or if you worked, fully articulated five-bladed or whatever, you have to have a different mindset coming into the 407. You have to understand that we're going to use hub weight, PCLs, product balance, and tabs for the whole ride.
Mm-hmm.
And not just for initials. A lot of like two-bladed rotors, you work tab when you leave a hover, and that's pretty much all you do. Maybe a little span weight.
Yep.
407, I'll use hub weights clear up. And 70% of the time when I'm finishing a 407 rotor, I'll throw hub weight on, and that's it, and it'll finish the high end.
Quick acronym definition for the PCL, just for listeners that don't know.
Pitch change link. Yep.
Thank you.
Pitch
Yep.
change
Okay.
link. Yep.
PCLs.
Yeah.
Okay. Looking on to what we're going to be talking. And 407 is a great platform. It's so, like Martin, you said when it came out, she was probably a little stressed, but now she's a workhorse. She's a workhorse. You hear a 407, you just the distinct sound, distinct look, and distinct performance, right? So
Yeah, it's
strong. It's fast.
and it's smooth.
I love the 407.
Yeah.
Looking at Nodal, Nodal, the Nodal beams in the 206L on the roof. Again, probably need a definition of the Nodal to the people that are just listening on this one here.
It's a nodal-matic is what it is.
Thank you. Yep.
Okay.
Yep.
Yeah.
Okay.
And believe it or not, we used it on a few different models. The 206Ls and the 214s.
Plain rotor versus stacked rotor split.
214s were two-bladed underslung. So that's where it's most effective, is on a two-bladed rotor.
Martin, you want to jump in on any of that?
Just a question for Greg. On the 222 and 230, do they call them nodal wing?
They did. That's correct. They did.
Okay, they call them?
Yeah,
Okay.
yeah, they did. Yeah.
Another iconic platform.
I only had exposure to the 430, so I don't know much about the 222 and the 230.
So basically, the nodal suspension canceled out the two-per vibrations by a flexure. So it would react at the same frequency in the opposite direction. So the transmission sits on these flexures, and it moves vertically and reacts, to dampen the two-per-rev. And you can make a 206L can be really smooth aircraft.
No, and they stay smooth. That's the nice part.
The L's, yeah.
That's flying carpet.
And you know what? That's the unfortunate. Like, there's not too many L's still out there. Like just the plain L.
Straight L with the C20s in them. I think there's one in there in your area, Martin, in Quebec. There, I think there's
I got
one.
a world fleet upstairs. Like that's a part of the it's part of the job that I look at. I see, like, back in the days when I was with Chematics and K-Flex on my regular job, there was like people always asking, can I get one for this? I'm like, you really can't. Like they weren't being produced, right? There was just that nice, and mind you, they've now jumped into the L1, L3, L4 kind of scenario, right? So but the L platform is a beautiful platform.
Yeah, it worked. It was a platform that worked. It was a growth out of the 206, B model.
Yeah.
So you got a little extra room in the cabin, and I will say a better ride. It flew better than not that the Jet Ranger don't fly good, and they can fly really good, but that note all changed the ride in those aircraft significantly for the better. But the progression was the 206L was C20s.
That's right.
Then the L1s come out with C28 in them.
Oh,
and then
The engine guy.
engine guy. That's exactly it. Pulling out my fingernails in the C28s.
Yeah. And then the variants with the C30, and most of the L1s have been converted to C30. I rarely see a C28 L1 out there anywhere. They've all been upgraded to the C30P.
I know of a gentleman down somewhere in Texas there. I don't want to kind of give him too much infamy right now, but he's got all the C28s, everything you can possibly imagine stacked in his hangars.
Yeah,
crazy.
Good for him.
Yeah.
Yeah, good for him.
Martin's like, I wash my hands of this. Nice, guys. Okay, that was awesome. That was quite a bit of information. Thanks for all this, but we're now going to get into the steps to check before equipment installation. I'll lean on both you guys to jump in on everything involved, from cleanliness to oil and cooler impeller and stuff like that. So lead away.
Before you start, going down the track and balance road, you want to make sure you don't have any mechanical looseness or excessive mechanical looseness in your flight controls, like collective levers, the swash plate, the sleeve, pitch link bearings, all that stuff. You want to make sure your blades are clean. You want to make sure on a 206, you want to make sure your hub's lubed up. Make sure you don't have an excluder blowing out. And you can do that by simply pumping grease into one or the other and counting the stroke, the grease gun pumps before you get grease out the vent hole. It's good housekeeping. Clean the blades, grease your rotor hub, make sure all your controls are tight at the swash plate area, and look at your mounts, your transmission mounts. We'll see a lot of times where we'll try to get into a situation, especially on like the 206s, where I got this vertical in the hover, I can't get rid of it. Turn your blades 90 degrees to the fuselage, get somebody out on the end of the blade, put your fingers between the rotating and non-rotating portion of the swash plate, and have them try to pitch the blade. If it pinches you at all, you need to get things tightened up in there. You got some play there. You can see the stovepipe, the sleeve moving on the support, all that stuff. But to get started, clean everything up, have a good visual, make sure you got some good tight components.
You can't balance dirt, right? Can't balance dirt,
and it's really hard to balance an aircraft that has worn out components.
Yeah, that sentence is from Greg Arnold, and I think it's really good. Don't balance dirt. So get your oil cooler clean, your fan shaft, and that's a very good point.
Yeah. And coolers are a big thing, 407 especially, but even on the L models, clean them up.
Oil coolers,
clean your blower, your squirrel cage. Get the sand out of them, because it all gets collected in there, and centrifugal force just packs it in there tight. Clean it up, then do your balance. And when you're doing that cleaning, just be conscious of your bearings and make sure you grease them afterwards. Don't grease them before if you're going to use water in there or everything. Your hanger bearings on your tail rotor drive, tail rotor trunnions on the tail rotor for the greasable trunnions. Make sure they're tight. Make sure when you flick the blades before you start balancing that they only bounce once and a half or so. They don't just sit there and bounce back and forth. Your trunnions loose. You'll beat yourself to death trying to balance that.
Gotcha.
And the elastomers, have a good look at your elastomers in there. On the 407, the 429, you end up with we have elastomeric flapping bearings. Make sure they're clean. Keep them clean. Have a look at them. Make sure they're not crumbing and the move lines are moving together when you flap them side to side. Just general visual stuff that will save you a lot of time down the road.
Swash plate friction is a big one as well.
Okay. Absolutely. Okay. Tilt friction on your swash plate. Absolutely.
Another couple of points here is inspect transmission mounting corner mounts, especially on 407s. Charge live mounts.
Corner mount, you don't need the tool. You can load the aircraft and just use a sling in a hanger, and you see the gap for your corner mount and inspect them. That's easy. And we have a puller that we can use, but most of the operator, they have a hanger with the hoist. So that's one way to check the corner mount. Live mount. You want to talk about live mount, Greg?
Yeah, really. Well, let me talk about the corner mounts one more thing.
Yeah.
It's important when
Okay.
you're inspecting corner mounts to look at the bottom side of the corner mount. You need to get it up to where you can see underneath the corner mount with a mirror, because that's where you'll see the tears in the corner mount. Because think about it, it's an elastomer that when it's sitting there static on the ground, it's not loaded, right?
Yeah, right.
So as you pick those corner mounts up, simulating like you're flying, the transmission picks up on these corner mounts. You can see where the damage will be is on the bottom side. It's much more prevalent to see the tears in the elastomers on the bottom side of the corner mount. And then for the live mounts, they're charged with nitrogen. We have this thing where we say, check the charge. Well, I'm going to tell you, it's pretty hard to check the charge because the volume these live mounts hold of nitrogen is so small. The better thing is, as Martin stated, charge your live mounts. So just recharge them. And, I've had folks do it a couple different ways, but there are ways to check it. So when you first put the tool on and you open the Schrader valve, just record where the gauge went to, what the reading was, then charge your live mount, record that, whether it's 180 PSI, whatever it is, on a different charge for different aircraft. But then you go back to that. If you just want to check it, you can go back to it in an hour, check it again, and see if it's leaking. And if it goes right back to the same number, then you've got a good live mount. If it's higher, then it bled off somewhere down the line. There's a couple of ways to do it, but really just charge them. It says check the charge of the live mount. Because of the volume so small in there, it's really hard to check the charge. Just recharge them.
Gotcha.
And all you're doing is charging them with nitrogen. That makes sure they have the correct pressure in there so they react the way they were designed to react.
With nitrogen being less flex, more consistency. Yep. Gotcha.
Yep.
Collective lever for play?
Yeah, that's the pins. On the collective lever, where it attaches to the sliding sleeve, there's pins.
Yep.
Now, there's also bushing in the H-link where it attaches to the support. You need to check all that. And it's really hard to do if you got the weight of the rotor on there. So what I'd recommend folks do is disconnect that link from the bell crank.
Yep.
So there's a bell crank and a link goes up to the levers, the collective levers. Disconnect that link and then you can wiggle that bell crank back and forth. And if there's play, you'll see it right there.
Okay.
And it's one bolt.
That's something to check. All the little things we're talking about is the basic check. And when we have a customer calling for problem with two-per-rev or four-per-rev, that's always the same checklist that we're asking the customer.
Okay. There's an FAQ then, or at that point, right? So frequently asked questions. You guys are quick on the answer with it. You know exactly what they're doing at that particular moment. Love it.
Well, that's why I say don't get frustrated with us when we ask you to check stuff that you probably already checked once.
Mm-hmm.
But we may have a different way for you to check it. So
gotcha.
If we have enough experience to know what causes a lot of these issues generally, like vertical in a hover, vertical on the high end, lateral issues. Just don't get mad at us when we're saying, hey, double check this, would you?
Greg, so what I'm hearing is that old adage, there's more than one way to skin a cat.
That's right.
Okay. All right. All right.
Yeah, but Greg had a good point. After 3, 4, 5 move, if you're not going anywhere, just relax, check your setup. It happened to me. I'm sure it happened to you, Greg, a few times.
Oh yeah.
In my case, so wrong channel, because when you're switching from one model to the other, you can't remember exactly. At least I can't.
No, I know.
Remember everything. So double check your chapter 18. Check your channel. Check the Excel location, and that's the basic. Because if you're not going anywhere after 3, 4 moves, there's something's wrong. Gotcha. Either mechanical or on your setup.
Yeah, and the other trick is if you make a move and it plots out, and I always recommend when you start track and balance on any model, get the paper chart out, plot your moves, plot what it's doing.
Okay. If
it goes 180 degrees, if your move goes 180 degrees, go check your orientation of your accelerometer. Because it's like 180 out. Double check your orientation.
Gotcha. And that could all be, like you said, it's a proper domino effect that if one step wasn't checked, probably a different way than what we're used to. Second check is then off, third, and sort of like it's literally a following domino effect that if one is slightly out, they're all going to be slightly out. And it might be just the way they're doing it. without properly kind of either talking to you guys about it.
Another point is take notes of what you're doing. If you're doing a product balance move or a tab move, take notes. Okay, that flight I've done the pitch link and tab. So if you're having problem to reach to the center, it talks to you. I mean, you need to know what was done on the rotor.
Mm.
And we provide the move log in our maintenance manual. You can print out as many pages as you want. Use that move log. And why we're talking about that, when you finish your rotor, record your tab angles, record everything you can put it in your logbook entry, but put it in the move log in the work order or whatever, especially on the 407s. I recommend when you finish your moves, measure your tabs, write the tab angle on the top of the blade and marker.
Gotcha.
You can go back there quick, double check. If the ride changes in a few hours, go double check your tabs.
Okay.
You may have had one washed out. That's typically what happens.
Excuse me. Solid advice. Perfect. That was, again, here we are. Good chunk of the show. We've covered quite a bit. And we've only scratched half of the stuff, which is even awesome.
Exactly.
We're going to the install side of it now. From what I'm told, always use rigid bracket for accelerometers.
Yeah, I saw something in the field that people are making brackets with sheet metal, but you need something rigid like this block.
Okay.
That thing won't shake at the knee. It was shaking only in one direction. Really important because we've seen some cases that the guys,
just hold that up super close to the camera there, Martin. Let's see that thing. There you go.
See, it's a block. This one is aluminum.
Yep.
But that's what you need because if you have a flimsy bracket, it won't work.
To Martin's point, I've seen some pretty creative stuff in the field. But it has to be rigid so it reads the frequency off the airframe correctly. And also, make sure you don't have cables laying on the accelerometer. Make sure the loop for your cable coming off the accelerometer is tight. Is not just dangling out there because that'll interfere with it. Especially on like a tail rotor, we have pretty specific instructions for tying up the cables and all that. It's all those little things add up to frustration if you don't keep a tidy house up front, right?
Chat a little bit about the rads or the Zing paint blade leading edges.
So the way the camera works on the rads and the Zing is it's looking at that blade as a whole, and it's looking for the interruption of the beam. So if you have, and it's a reflection. So if you have the leading edge 2 inches that's silver, and then the black section, it only sees the black section, and it'll maybe pick up the leading edge of silver all the time. We want a consistent color from the leading edge to the trailing edge on that blade so that the camera picks it up accurately. And it measures the time. It times when the beam's broken and when it's going away again. That's how it knows how far away the blade is.
Okay.
So that's how it picks up the track. So in our notes, we always say, wrap that black paint around the leading edge on top, just a little bit on top of the blade, so you don't have any reflection off the silver, the leading edge abrasion strip that's silver typically, so it doesn't interfere with the camera.
Yep.
Camera angle is critical on these aircraft.
That was I was just going to say that the tracker angle is probably one of the more important here, isn't it?
It is, yes. Yeah. Martin, you want to talk about the best way to do that? Because
just one word on the, it may work without painting, but you're looking for trouble. You won't get consistent values for your track, which is really important for the initial mode. We tried it here in production. It works, but it's not consistent. So take the time to clean your blade and put the stencil ink that they call.
While we were talking about the angle of it all, did you want to chime in on that as well? Yeah.
Yeah, that's critical because you're measuring, and it's a triangle that you're measuring for your distance of the track. So it's critical. Another thing on the tracker, you have like a shield that you can put. It's optional, but especially during a big sunny day, you may have some error code on your tracking if you don't have that shield. It's just a cover that you're putting over the tractor.
Some type of sunshade.
Yeah. And I've seen it bright enough on a cement tarmac that we couldn't get track on the ground.
The reflection initially. was that much off of it? The gleam.
Yep. The white concrete.
Okay.
Was reflecting enough off the bottom of the blades. And Flagstaff, Arizona. So if you ever track and bounce in Flagstaff, get off of the tarmac. Get so. No, but so there's the point is you don't want to be flying into the sun with the tractor. You want to make
Roger
sure
that.
the sun's either 90 or to your back.
Yep.
And light's critical for the tractor to work correctly. So you need it. And it's the same with the photo eyes on the tail rotor. I've had that happen where early in the morning you got the sun shining on the same side of the blade as you're trying to pick up your tacho on with the reflective tape, and it will mess that up too. So just something to think about.
Yeah. Solid advice. It's all time of the day. Go ahead, Martin. Yep.
Great. Do you ever use a flag to track 206?
Never 206, but Bell 47. Yeah.
Okay. Oh,
Yeah.
oh, you're that old.
Hey! Now
Shots
there's
fired.
there's still 47s around. Come on.
Not in Canada, as far as I know.
Oh no, there is.
No.
There
There is.
There's a lot
Oh, yeah?
west. Out west, yeah. Out west. Yeah,
Chinook
there's-
has. Yeah, Chinook
That's right.
has
Yeah,
them,
Chinook
right?
Flight School has a bunch. There's I even see them around Winnipeg still with the old running joke in Winnipeg, mosquito toba, right? So they still use them for mosquito controls. Absolutely.
Because when I was in the field, we were using the Chadwick with the strobe light, and when I started here in production, the guys, I thought they were playing a game on me. How come you're using a flight, guys? And then they come up with the rods, and it's much easier with the rods.
So
now.
using a flag to do it.
Yes.
Oh, okay. Explain. Elaborate.
It's kind of a U shape at the top of a pole that you put basically a flag, and you put in colors at the tip of your blades.
Yep.
And you go close and tick, tick. The first time it's not natural to go.
Yeah, no,
close
it's
up the road.
Yeah.
It goes against all the safety
no.
things wherever it's
No.
don't
Whereas-
get near the road.
Yeah,
Fair.
when I started, I thought the guys were playing games on me. I said, "No, you do it." And
I've heard of first aid jokes when they're like, get the newbie out there, get the fresh AME out there to count how many times it rotates in the first minute. This is right up there with it. And we're good. We're out.
Yeah, it's another bucket of rotor wash, right? So you got to go get a bucket of rotor wash. So,
Yeah. Yep.
No, so we used that at one point in time. We used to use the crayon method on the tail rotors too for tracking the tail rotors when we had adjustable PC links on those. So
Yep.
I mean, it works. You just have to be. It's definitely unnerving. And then there's also, it used to be in the L1 manual where you'd put tape on a blade and you would put weight and bend a tab or whatever. You'd wrap the blade with tape, and if it got better, you put weight on that blade, or vice versa. And you could do it without any equipment, and you could get the ride pretty darn good that way. If you bend a tab and it gets worse, go the other way with it.
God bless
It's
technology.
crazy.
That's all I got to say, Greg. God bless technology.
Sometimes you just have to keep it simple, though, right? If
I
it
guess,
works.
when you have that kind of complexity, it's the KISS rule. So at that particular moment.
Yeah, it's some pretty crazy stuff.
Yep.
it's like
Go ahead,
I
Mark,
just
then.
think of from there's no black magic. You add weight. If it goes better, you keep adding weight till it gets worse. And if it doesn't improve, you remove weight till you have a smooth ride.
Let's get on to the gear track and balance towards 407 models here, guys.
With the 407, it's a little unique in the fact when we install our equipment, we have a fore and aft accelerometer in the nose. We have a vertical in the nose. We have a vertical in the aft cabin. And we balance the ride between the forward cabin and the aft cabin to give it the best ride for all the occupants. And that's done through the program and the coefficients in the rotor system, in our RADs or our Zing, Honeywell ZTE kits. So, like when you're installing the camera, angle's critical. Make sure you're setting the angle. And we tell you to use the baggage compartment deck, zero your level, go out and set it at like 55 degrees, I think. I look at chapter 18. Don't quote me on this.
Yep.
Hold on. Let's just make that clear. Look at chapter 18. Don't quote Greg. Yeah.
That's right. read
Let's be clear about
chapter
this.
18. Read chapter 18. And actually, to get started, before you even put any gear on, and before you start tracking, go read chapter 18. Go read the task of what you're going to do.
Takes 5 minutes.
And you'll learn so much there. We all think we've done it. I go back and occasionally just read it when I'm getting ready to go help somebody to make sure my mind's working the right way. I'm not missing something. So
It's worth a 20 or 25th read.
There's some good troubleshooting tips as well in chapter 18.
Gotcha.
Yeah, frequencies, all that, stuff
Yep.
you can learn and what you need to look for. But when you install the gear, like anything, make sure your cables are secure. You're going to run a cable from the camera back through the chin bubble. We recommend going through the drain hole in the bottom of the chin bubble. Some folks will run it down the side. Just make sure it's secure. Make sure everything you mount is tight. The other thing, especially on a 407, when you hook up your mag pickup, your RPM sensor on the swash plate, there's a harness built into the airframe, and it's stowed on the harness on the transmission with a cannon plug that just plugs into your mag pickup, your magnetic pickup. The interrupters are already on the swash plate, should be under the green blade, correct, Martin?
Should be steel.
Should be steel and under the green blade. Yes.
Let's
Because we've
reiterate,
seen some
should be steel.
aluminum. It's like, I can get the RPM. Whoa.
Should be steel.
And make sure, you have a service loop in that cable going to that mag pickup. Don't tie it tight, because that whole assembly's got to lift up, and I've seen it more than once. I got everything tidy up there, nice and tight. They pull into a hover, lose their RPM signal. They just pull the wires out of the connector because it's too tight.
Yeah.
So it's just a little tips and tricks there,
Gotcha.
And cleanliness is a good thing with your cables in the cab. I recommend you color code your cables so you know which one's where.
We've been a part of a couple of podcasts here now, Greg. I think cleanliness has been a theme of every one of the shows.
Yes.
Be nice with your wires because they're really expensive.
They are. Yes.
Thousands of dollars.
Yeah.
Don't be slamming them indoors if you can avoid it. Right.
Yeah.
So,
yep.
But I quickly, when you're hooking up fore and aft, if you're color coded or you're numbered on each end of your cables, you run a lot less risk of getting across and starting the frustration of track and balance by having mixed signals to your collection unit.
Gotcha. One last note, it's telling me that product balance adjustments are typically only done the initial PB not in flight. On a rare occasion, a 412 PB moves can be done on in flight. Want to elaborate?
Correct.
Okay.
Martin?
Okay.
I don't know the 412, so maybe you can continue with the 412, but product balance is very simple. You're 100% on the ground, and when you're pulling torque to get in hover, if you have a blade climbing or diving, that blade needs product balance. So on a 412, I don't know how you proceed. It's probably the same logic.
Same on the initial stuff, but we can use it to twist a blade in flight too. So
There you go.
we use product balance to control how much the blade twists.
Okay.
If we make the leading edge heavy, it doesn't twist as much. If we make the trailing edge heavy, it twists more. It's a way to fine tune that blade, and it's more prevalent we use it a lot more on the fiberglass blades with the honeycomb core than we do the carbon fiber blades with the foam core. I can be honest with you, Martin. I don't think I've ever done product balance on a 429 blade.
Okay.
From
I
the
never
factory.
did either. I never did.
Not on 429s, no?
No, but it's there. It's an option, but you don't use it. But the point is, in manufacturing, each one of these blades, it's hard to control the contour perfectly with a composite blade.
Yep.
So you're always compensating for the differences in those blades from the master blade. And one of the ways we do it is with product balance. And we use it, like Martin says, you pull into a hover, you measure your track at 35% torque in the 407, 100% NR, 35% torque. Then you pull into the hover and you see how much the track changes in those blades individually, and you may have to adjust them. It's more often than not, we'll see adjustments, product balance adjustment needed when you're mixing blades that have been repaired.
Yep.
If they've had a repair, they're heavy on one, and then you end up doing a little more adjusting of product balance that way. Yeah, we use product balance more for adjustment blades that have been repaired and mix and matching blades with different times on them. These blades erode as you're flying. The leading edge erodes, it changes the mass of the blade, and you may throw a new blade on with 3 blades that have 2, 3, 4, 5,000 hours on them. They're going to fly different, and you have to adjust them.
Different stiffness. And just for your info, 407 early days, there was no option for product balance.
There was not.
No,
I remember those days.
Yeah.
Oh boy.
And we were having, as Greg said, we're having a pile of blades in the corner in the shop, and nobody wanted to touch these blades. So that's why we started to do product balance. Because,
Okay.
And it's really easy. Once you understand the principle of product balance, it's really easy.
Yeah,
So
it's you're just basically
it's not a science project.
no, but the key to product balance on a 407 is maintaining your weights.
Product balance, guys, a word of advice, take the time to do a good initial. You'll save it, unless you like to fly.
Yep.
Take the time to do
You're like burning holes in the sky. Just don't do the initials.
Yep.
To make this point, the 407 blades are whirled on the whirl stand with the master. And on the root of the blade, you'll see a tab setting and the weights that are in each of the pockets, forward and aft product balance weights. If you're having ride issues you can't clean up, you need to double check those weights are correct. There's a couple different philosophies about starting initials on a 407. I've done it both ways. I've zeroed to cord and I've zeroed to the tab setting on the blade root. And more often than not, the tab setting on the blade root gets you in quicker. But it also means you have a fair amount of tab, and you could end up with tab up on all four blades, which on another, like a two-bladed rotor, if you got both tabs up, they're fighting each other, right? So you have to keep that in mind as you're working the rotor. But those measurements are there to use. Make sure your weights are within 8 grams, I think is the limit there, Martin, right?
Yep.
On like 4.5 product balance pockets, make sure they're within 8 grams of each other in each pocket.
Gotcha.
Or total if they've been adjusted.
I don't recall exactly, but go to chapter 18. It's all there.
Chapter 18 explains it all.
Chapter 18. Yeah. And
Yep.
and there was a TB. Did we incorporate the TB into the manual? I think we did. That we did initially. We had a TB for product balance on the 407 blades. But we do use it on the 412 as well. You use that, and you can use it in flight to help twist a blade, bring it in. It's one of the options. So
When it says here, it's asking we're just another acronym, the TB, track and balance.
track and balance. Yep.
Yep. There we are. So again, just a couple of times just with the acronyms. I know we all know them, but just to kind of explain them, it's always good.
Yeah. No, it is good. Yeah. We take it for granted that everybody, and different manufacturers use different terms for the same thing. So it's important to,
It's going to be relevant to the particular area of the helicopter too, because like I think one of the other notes here is like it could be also tech bulletin, like technical bulletin in an entirely different location, right? So that kind of TB is noted. But when we're talking this track and balance particular segment, this is where the T and B is going to be track and balance. Oh, there we are. Okay.
Initially, the tech bulletin come out for product balance before it was put into the manual.
There you go.
So
there you go. Perfect. Next one is going to be talking a little bit about 429 on the tail rotor drive shafts. This is the good stuff.
Yeah,
it's all you, Martin.
No, Martin, you're getting leaned on this one now. This is it.
That's what we call the critical drive shaft. And
that's right.
Early in the program, we had problems because it's kind of I'm not a specialist for composite, but the glue or the resin to put in the shaft was not drying at the same rate. So they need to rotate the shaft while it's dry because we had some puddle, if you want, of adhesive at the bottom so that it was shaking like hell. So now they mastered that. And the vendor, they spin the shaft, they balance them, but not 100%. They probably don't have the setup. So I was told it's 50%. So 3,000 RPM. It's decent.
It's still pretty decent. Yeah.
Yeah, no. As far as I know, we don't hear. You hear in production at least, and neither in the field. There's very limited damage allowed on those shafts. Very limited. But we don't have any dynamics issues with those shafts.
No, typically, if we see something in the field, first of all, they're carbon fiber with metal couplings huck bolted on the ends. Okay, so they're a carbon fiber tube, like Martin says, and there was some issues with manufacturing, but they got that sorted out. So they master balance them. But if we see an issue in the field, we'll just rotate them a coupling. We'll rotate them one bolt, one direction or the other, and eventually you have basically three settings. They're 3-bolt flanges.
Rotating to about a 90 degree is what I'm reading.
It's a little more than a 90 because there's only 3 flanges. So
I got you. Okay.
Yeah, like 120, I guess would be.
And if it doesn't work, you can flip the shaft over, like the front end at the back end, and vice versa. So usually we are with that solution, clucking and flipping the shaft, we're good. I want to show you something regarding the drive shaft. Greg,
please.
You've probably seen that before. It's what we call a hand probe. This is an XL, okay?
Oh yeah. Yep.
And Dan Prairie was chasing an aircraft like for 2 months, and they were taking data, and it's we have to make sure the way the customer is taking the data, because here we can go on a flight line and take some data, but if you're not taking the data a certain way, like the big argument from I won't tell the customer, but he wanted to know what kind of level of vibration we had on the drive shaft. I said, I can tell you that the number as long as you take the measurement the same way I'm doing it on my hand here. And there was kind of a fight, not Dan, but they were very reluctant to get this hand probe. And the customer wanted to return his aircraft because he was complaining for a vibration. And drive shaft, it's a high vibration, so you can feel it in the floor. And they took a set of reading with that tool, and we were able to identify there was a second shaft that was vibrating way too high, and we just clocked, like Greg mentioned, and we got rid of the vibration. But we need to understand how you take the data, because you cannot install an XL wherever you want. It doesn't mean anything in some cases. So
it needs to be like for like.
Yeah, give us a call. We'll give you direction and some numbers that we can compare, and we can tell if you're way out or you're close from the truth. Or don't be shy, give us a call. And we have a really good product support with the engineering. I talk to them every week, and they're really good guys. They're there to help, and they have a lot of knowledge.
Awesome.
And they're working for Bell. So
consistency is the key, and pictures are worth 1,000 words, as we've heard how many times, right? Send us a picture of your install. Send us where you're taking the readings. A picture, it's too easy these days. It didn't used to be. Now it's too easy.
Well, it kind of jumps into the next topic here. And like with technology, you're right in our pocket, right? So it's we're able to kind of really communicate at literally the speed of lightning nowadays. Like it's one.
Yeah.
And let's elaborate on what we can do with sounds, vibrations, and what PSC team can do with the monitor. I think we just kind of touched base on it just now, but we can kind of talk to you a little bit about that as well.
Yeah, with the technology today, a regular cell phone is very powerful to take a sound sample. You go in the configuration where the aircraft is, I would say, quiet, take a 20-second sample of that, and then go to the worst noisy configuration, I should say, or what the worst configuration you can feel, and take another sample, send that to product support, and then we have an application in engineering that they can compare, and they can identify the frequency. So they give you an idea, not all the time, but most of the time they're able to pinpoint what's guilty in the system.
And you guys have an application in-house for that?
Yep.
Yeah.
That's impressive. That's really impressive. And I'm sure if it was just even off, just resend another soundbite. Like it's
too easy.
That's fantastic.
And really what Martin's talking about is the next generation of health monitoring systems.
Yep.
They're basically microphones listening to the noise on the airframe. Every gear
Gotcha.
that turns at a certain RPM makes a unique noise.
Yeah.
Every bearing makes a unique noise, all that. And we know the noise footprint.
Pitches and howls.
Exactly. And it's that's where we're going in the world, in my opinion.
Hey, you see that, Martin? Engine guy. Pitches and howls,
baby. Yeah. You know all about it. You can't hear it anymore because you were too close to him for too long.
Yeah.
But
Yep. That's awesome. That is excellent to know, Martin. That's the fact that they can kind of take that soundbite and chuck it right into your application and kind of determine what the issue is right there.
I remember a case like I had no kids at the time, so it's at least 25 years ago, at least. And it was in UK. Customer, a rich guy, was wanted to return his aircraft because they couldn't pinpoint. And I asked them to take measurements a little bit everywhere, and I was 95% sure it was not a dynamic issue. So they sent me with an acoustic engineer from Fort Worth, because at the time there was no cell phone.
Yeah.
And we were able to find the problem. It was like a whistle in the aircraft. And what was wrong, it was the retainer on the windshield. There was a lack of sealing, and it was whistling and dive. So I got there. I double checked all the frequency, and I was to confirm that I was 95% sure it was not a dynamic issue, and so the pilot was kind of more willing to fly the aircraft. And after 2-3 days scratching our head, we fixed it with a piece of tape. So it was a really expensive piece of tape.
You just went red green on that one, man. Nice work.
But that was good. That gave me a chance to go in UK for a visit.
Nice.
And to Martin's point, to add to that, the reason we prefer to take troubleshooting readings with the RADs or with the Zing is because engineering has the software to diagnose the data we provide, the downloads. Okay. And we can do spectrums on the airframe and analyze airframe issues as well, different unique things. As Martin said, we've all had an experience. We had a situation with an operator in California where they had this really unique noise at low power settings and letdown in a 407. It turned out to be input pinion gear was cracked.
Okay.
And you'd only hear it when it was unloaded.
Yeah.
So
it's one of those load bearing parts. Yeah.
Yeah. So it's an impressive tool,
It's fantastic. That flows right into everything that's AI and tech nowadays. Love to hear it.
Yeah.
Love to hear it.
Yeah.
Last segment here, guys, before we kind of get this rolling here. This has been very informative. I'm sure there's a lot of information, but last one will be tips and tricks. So it says here, make sure you install equipment on take readings /data and not just pilot.
You're feeling something. What are you feeling?
Yeah.
I'm nothing against pilots, but you're feeling what? High frequency, low frequency. So where you feel something, you can use this probe or build yourself a bracket, install it on a co-pilot seat take some measurements and then, we'll find the frequency and then is it a hydraulic pump? So it's easy to call, I have vibration. Okay. What kind of vibration do you have?
Yeah.
And be consistent, please. When you're comparing stuff, make sure you're same fuel load, same gross weight. Like don't take a set of reading pilot by himself as opposed to a 6-passenger. It's not the same configuration. So,
and I'll add to that on the 407 and on all our models. When you get out of initials and get into hover and start your first forward flight, check your auto rotation RPM and adjust it first. Do not wait till the end. You'll backtrack some and you'll get frustrated. It'll take you out. The minor adjustments you're going to make on a rotor after you've got it flying will not impact the auto rotation RPM anymore.
Gotcha.
So get that. And safety wise, you want to make sure you can auto anytime during the track and balance evolution if you have a problem. So do that first. It'll save you a lot of heartache and pain down the road. It's
a couple of other ones here I noted here is try to keep gross weight within 200 to 300 pounds.
Yep. That's what Martin was saying. Keep your fuel loads consistent. Yep. And keep your body count the same, whatever you're doing, just be consistent. And I can't say it enough. Yep. Consistency is the key to help us troubleshoot with you.
Adjustment on the coefficients. Yeah.
Yep. Oh, let's talk about PCLs on 407.
Please, yeah.
Tips and tricks. So you're moving barrels top and bottom. There's a couple different tricks, but it's critical. And it's same on 206, all the aircraft. Make sure your lower rod ends are aligned in the swash plate.
Okay.
If they're off alignment a little bit, they can be off by 20, 30 degrees. You may not think any of it. They can actually chew into the swash plate area if they're too far off. But even more so, it's not a true move if you're off by 30 degrees on one and you're squared up on the next one. Just that change in thread count, a little bit of thread pitch there, adjustment makes a big difference and we're talking millimeters here. We're moving millimeters at the blade tip. So you see how small that has to be and check for looseness. Like I said before, record your tab angles, record all the information when you're done. Have your move log. If you're having troubles at all, pull a chart, plot it. Make sure the moves you got, your how it moves on the chart is what the machine's telling you it's going to do, prediction wise. And then you know you've got valid data coming from your machine.
Gotcha. There's an interesting bullet here. It says ground bounce.
Oh, ground bounce.
Yeah. Yeah.
Never heard of it.
Who's going to get into this one here?
In the early program on the 407, we were learning, and typically if your rotor is 25, 26%, 100%, and negative pitch bring you ground bounce. So that's why we ask when you take measurement to pull minimum, not minimum, we ask you to pull 35% torque.
Yep.
To get out of that ground bounce and get a solid measurement.
Roger that. Okay.
Loads up the corner mounts and all that on a 407 to get
Exactly.
you a clean ride. And ground bounce is a direct result of auto rotation RPM adjustments.
Okay.
So on the 407, if you look at the auto rotation chart on a 407, 407's most pronounced is the one the most pronounced with ground bounce. Although all of them can get it if they're in the negative. Or if you want to get it a theory.
I was going to say we're squeezing in on some time here, but I'll knock out these bullets here, and we can kind of just we'll do a quick little shout out to him here. It says torque around 35% on ground for measurements on a 407.
Yep.
Unable to reduce main rotor vibe check on tail rotor balance. 407 tail rotor vibe can be felt in floor mainly.
Yep.
Check for broken instrument panel shock mounts. I think that's got to be pretty epic.
That's a 407 thing. There's
Gotcha.
elastomeric mounts on the bottom where the panel hinges.
Mm-hmm.
There's some elastomeric mounts there, and as we've seen customizing and more radios added and all that, we actually come out with a bulletin to add another rubber isolation mount there. If that panel sits down on the vertical panel and starts vibrating, it picks it up, and the accelerometer is mounted on the side of the pedestal right there, and that's why you want to make sure you got a nice clean. And besides the fact, if they're touching, the gauge will be blurry when you come into land or take off. The whole panel will be shaking too much.
Yeah.
So,
Okay. Here for spectrum measurement mount accelerometers where you feel the vibration.
Martin touched on that already.
Yeah.
Right?
Yep.
A lot of people don't know what there's an ERAS. There's a function, a spectrum. Spectrum is a sweep of frequency. You have two options. You have 0 to 100 hertz and 0 to 1000 hertz. So that's mainly the first thing we'll ask the customer. Let's say he feels a vibration on the co-pilot seat. Install an Excel and run a spectrum that will give you an idea if it's one-per-rev, four-per-rev, or drive shaft frequency.
So in addition to pilots having their feelings being talked about, they need to talk about their physical feelings. Yeah. We rip into pilots all the time. I love it. They're good people.
I have to tell you this real quick. I have to tell you this story. It just happened. I had a pilot complain, this thing just doesn't feel right. It doesn't feel right. And we flew for like 6 flights, taking readings in an afternoon and come back. And he was standing there, and to his credit, he's standing there and he goes, I want to go fly one more time. And he says, I think I'm the problem. And of course, we're not going to argue with him when he says he's the problem, right? So
maybe the man was doing a little introspective reflection there. Good for him.
He had his wallet. He normally flew in a flight suit with his wallet down in his pant leg. He had his wallet in his right back pocket.
Oh man!
And the aircraft
so he himself was out of balance.
He said the aircraft just isn't sitting right. It doesn't feel right. It's not, So all those little things add up.
Yeah. Perfect blade track is the goal, but not always the smoothest. Not always the smoothest ride.
Yeah,
that's correct.
That's the goal, but sometimes they fly better out of track. If you have a smooth ride, you're good.
So a smooth ride counts for everything.
Yeah. And mainly you'll see the out of track condition with the repaired blade mixed into a set of other blades.
Gotcha.
If you have repaired blades or high time blades, it's not uncommon to see a little bit of a track split.
Gotcha.
You have to be careful with track split, though. You don't want too much, because at some point they get too far apart, and then the ride is not good at all. It won't stay good at high speeds. But
gentlemen, an absolute pleasure, charm, and we actually ate up some good time on this one, the guys. This has been a heck of a show. I appreciate both of you coming in. Martin, thanks for jumping in with your expertise. Welcome to the MRO world now, vertical MRO world now. You're going to be you be signing autographs at Verticon and stuff like that now, right? So all 6 people are going to come up to ask you. With the Bell Tech Talk, I got to tell you guys, with the Bell Tech Talk, it's we've exploded, which is great because it means more people are listening to us. And what you guys are both providing, Greg, I've said this to you a couple of times now, but what you guys are doing is still it's Pathfinder. It is you're going out, you're making a difference to people that are actually listening to us in their earbuds while they're on the shop floor. So keep up the good work, and way to readily make yourselves available to the operators. So, and I'm sure they all appreciate you guys kind of having their backs as much as as you guys can with working your inner customer base to outside customer base. So I appreciate you more than that as well too. So
Hey, thanks to you, Val.
Yeah, thank you, Val. And
Hey, thanks, Greg.
yeah, Martin, likewise, thank you. Keep in mind, we're just a phone call away. Product
That's right.
support and CSEs, you pick up the phone, choose to text, whatever. Don't get to the point where you're so frustrated. It may be just something simple.
Yep, you're definitely not alone. Not in our world. So,
no, definitely. Yep.
But
thank you.
Have yourself a good one. Enjoy your family time here, and as always, a pleasure, guys, in sitting down with you and talking about all this good stuff. So that, I say thanks to our listeners, and thanks for listening to Vertical MRO. If you like this podcast, hit that subscribe button. And if you like the Bell guys, give them a crispy high five at Verticon.
Thank you.
Thank you.
Thanks, guys.
Thanks for listening to the Bell Tech Talk segment of Vertical MRO podcast. We want to hear from you. Have a technical topic for the team or a favorite technical tip? Let us know. Our email is techtalk@bellflight.com. That's TECHTALK @bellflight.com. If you're having a technical issue with the aircraft, as always, our team is here 24/7 at productsupport@bellflight.com. If you like what you heard, subscribe and come back for more.